Okay, sorry. I think we should better start the next section. Okay. So I'm going to chair this section, and I will pretty strict on the time. Okay. So this talk is again another invited talk by Todoro. Yes, it's talking about using astronomical data to teach the regular physics curriculum at high school and college.
Okay, good morning, and sorry for the rain. Well, it's not really a talk, it's a teacher's talk, just to share some ideas with the teachers and colleagues and eventually astronomers about using astronomical data to teach the normal physical curriculum. I think everybody knows the normal physical curriculum. This is the curriculum that will enter in Portugal next year, 2015. And in physics, for example, this is in Portuguese, but the words are very similar everywhere. Time, position, velocity, interactions, all curriculum everywhere, all countries have this type of topics. And in most countries, it's always the same. The car, the particle. There is no tradition of using, for example, astronomical data to teach this. About 1 year ago, I was in a workshop by Nucleo where they used this paper. I don't know if the author is here. Is not? It should be. And they show us a very interesting tool for data analysis, Sausage A, that I suppose most of you, if not all, know the software. And they used Sausage A to analyze the motion of a star around the center of our galaxy. And I thought, oh, this is too complicated. I'm more or less a tech person, but can we do that easily? And particularly for those teachers that are not familiar with even with the mouse and the Excel and changing from one program to the other, that's very easy to change the activity. And I've done a very small example. Well, the activity is basically the analysis of these pictures. This was published some years ago. You can see that you have a specific area of the galaxy, of the sky, and the particular center of our galaxy, with a distance scale, 10 light years. And you can also see the date it was taken. And if you make a movie with that, this movie is a little fast, but you can see, let's show it smaller, slower. There is a particular star that goes around something in the center. Well, I decided to change this to just collection of page with a dot and the scale. So it's just next page, no software, sophisticated software. And let's follow that star. You see we have the scale. Now we are in 2001. And we also have the distance scale. 2002, and that's the months also. Now a zoom of that area. You can see on the button the distance scale. Now, if we analyze that with a grid scale and the better zoom, we have now lots of information, well, some information, to start doing calculations. And the example I'm going to give, it's even useful for, then I simplify the image. So let's find the period. Even for writing an equation, this is a very simple equation. I hate equations with x and y, and so I think the idea of equation is most of the times hidden on the symbology that books and teachers use. And in this case, is an equation written just with words. And another thing that I think everybody should know, and I will recommend you to learn that, for example, on Wikipedia, is the use of the equal sign. When it appeared and how important it was for thinking mathematically, then you can solve the equation. So, a very simple piece of software, just next page, and you can create wonderful activities for mathematics, for circular motion. In this case, we don't know exactly if it is circular motion because we can see on perspective. We don't know if it is on perspective, and then it is an ellipse, but in that case, it will be the period of the ellipse, not of the circular motion. So that's an example. Another example, well, this is a little more, I don't know if it is an astronomy or not, but at least it uses some astronomical data that I think it's wonderful for data analysis. This is a movie on YouTube. I think it was Apollo 14. They made a jump, 16. They made a jump for Johnny Young. See, I don't know if they were doing that for physics teachers, but the famous example of leaving the tool, the feather and the hammer was done particularly for teaching physics. I don't know if this one was, but this is particularly interesting because it's easy to, again, if I'm going to use software, sophisticated software like even Sausage can be used here. The most useful in this case is one called Tracker, and there are Tracker is free, but there are some other that are commercial available. It will be for most teachers I know, even for those that are here in this class, in this room, that are some technically aware, they will have lots of difficulties. Can we do something very easy to use? Yes, we can. And the example I've made, it's a complete inquiry-based activity. It has a nice title, Jumping on the Moon, what can we learn from it? For our students now, they don't know what this is. Only those who are a little older can know what this is. It can even be an interesting way of starting a class. What's the relevance of that movie? And I like particularly when they start reading the book, and in 10 seconds, you read the complete dictionary and then complete Shakespeare. I don't know if you remember the scene, so it could also be used here. So the movie, you have seen it. Then we have an interesting problem here. What's the scale of the image? What do we have on the movie that can be used to scale the image? Well, it has this on the back. If we go to Wikipedia or to NASA, we found all the data about that, and the data includes the size of the bag that the astronaut has on his bags. So if I have a size, I can have a scale. If I have a scale, I can register, for example, 1 point on the middle of his bag with a scale on the right. It's zoomed for use in the class, so they can start recording data or on a computer, or on a spreadsheet, or on a paper graph. And also you can have a kind of stroboscopy during the immersion. And it's very interesting, here you have a discontinuity because he's jumping, so only when he leaves the moon, not the Earth, we can have some discussion about which is the better mathematical model for that immersion. Well, in the end, we'll have something like a table of data. Well, the table of data, the invitation is do it yourself, then make a plan the graph, choose the scales, etc. Lots of typical classroom activities can be done here. Then with the table of data, you get this data, wonderful. If you use difference to estimate the speed in each interval, you have a very interesting data with lots of discussion. What's the meaning of the first part, the second part, the third part? And then we can find some mathematical models. For example, for here you have you can find a mathematical model, and in the end, that's for the velocity. You can find estimate the acceleration in the moon and check how it is comparable with the standard. Well, again, it's a very simple activity, and if I have time, I hope this year I will have time. I will planning to do maybe 5 to 10 of these activities using astronomical data. Another one that I have here in Portuguese is particularly useful even for teachers because it's the scale of our galaxy. All of you know this image. We are on the Orion spur in the galaxy. We have a scale, but I like to use the term factor wow. Most classes we should use this strategy. Can we put the students with wow? That's true. This activity is this. We have this problem. I give students or teachers a small ball, for example, a golf ball. I have lots of golf balls because I live near a camp, and they lost lots of balls. So if this is the sun, where is the next star? And I give another ball. Let's use the same scale of our galaxy. And the interesting part is that this image seems that, oh, it's there, too compact. In the end, after making the computations and all the strategies, proportional reasoning, computations, etc., I will not show that to you. The interesting is the result. Next star is in Paris. So that's in Lisbon. We'll have a small golf ball representing the sun, and the next ball representing the next star is between Paris and Brussels, if you go on the right scale. So this is, at first time, that, oh, it can't be. It's not possible. Yeah, it's possible. So that image of the galaxy, it's completely mistaken by most people. Why? Because it's, if you go far, far, far away, you don't see individual objects. You see the all together. And another interesting issue about this problem is that can be also used. For example, this galaxy will collide with the next one, our nearest galaxy, Andromeda, in I don't know how many million years. But the computation so that there is none of the stars will collide with the others. So an interesting issue for conceptual learning. Oh, what's a collision? If they will collide, and now we can understand why they will not collide. The distance between the stars are so high that it's all very probable that they will not any physical collision object against object. Just to finish, and I think I'm trying to recover some of the time. This is a more advanced one that I use for teacher training and also for some students. Well, it's reproducing the reasoning that Newton used to discover gravity. What does it mean? What was his reasoning? This is a numerical method to simulate with real data the motion of the moon orbiting the Earth, and then we can obtain the trajectory. The numerical method, it's suitable for age 17 onwards. It's it's a very simple numerical method, so modify the Euler, and the results are very, very reliable. But you can use that with younger students because the speed of the moon is about 1,000 meters per second. So if we do some computation, well, this one is easy. If it is 1,000 meters per second, in 1 second, it will go about 1,000 meters. So that's about from here to the sea. And the question is, and how much does it fall? The moon is not going straight, it's orbiting, so how much does it fall? Oh, that's very simple, the computation, because we know that we have this mathematical model to compute the distance that an object with a constant acceleration falls in a certain time t. So Newton says that the moon is 60 times away from the Earth, the radius of the Earth. The law of gravity says that the acceleration and the force is proportional to inverse square. And if I want in 1 second, so this will be this acceleration times the acceleration on Earth, 9 point times, so it's that fraction of the acceleration in 1 second. So let's make the computations. So 1/2 times 160 squared times 9.8 times 1 squared. And (9.8) what? 1 millimeter. So every second the moon goes on 1,000 meters and falls to the Earth 1 millimeter. The first course that showed this was The Mechanical Universe by David Goodstein, and in the American English they used 1/20th of an inch. That's about 1 millimeter. And the first time I saw that, about 25 years ago, I never forgot. Because David Goodstein was saying, wow, so you see your inch? Now, the moon falls 1/20th of an inch. Well, in Portuguese, in Europe, since we use the international system, it's a little easy. Use your ruler and look at the 1 centimeter. Now, look at 1 millimeter. Oh, that's the distance the moon falls every second. And in every second, oh, this is absolutely fantastic to create the wow factor in classroom. So I hope I gave some examples on what I tried to say. Now I will show you finally my that's. Can we could use many other examples. For example, for light, I have wonderful examples also for light. And I don't know if you know, but there is a star database with star spectrum that can be used by students very easily. What's the temperature of the star? What are the roles used for that? So they can look at real data shared by, I think, star data. It's by Harvard Observatory, I'm not sure. Thank you. I hope It was clear?
Okay, great. I like the activities. Sounds great. Any questions? Okay.
You obviously have made a lot of materials. Are they available somewhere?
No, but if you send me an email, I can send to you. Well, there is a place where some of them are available. I have a Google Drive where I share most of things with teachers, some in Portuguese, some in English. So if you if you send me an email, I will send you the Google Drive. In once here, for example, I have also image, movies, and one. Well, this is not very legal, but not. Some short clips from Cosmos that are particularly relevant for teaching. There is one I really enjoy. I think it's this one, I hope. Oh, this is also interesting. What is science? So they are all there, but only clips, not the full movie.
Well, I think if you can provide all the with no license problem, okay, all the materials on a website, like say WordPress or all those stuff, will be very helpful for the people. Yeah, they can make use of them. I may consider. Okay, I have one question myself. So you have lots of working involved Excel's calculations, really precise measurements. And actually, I also asked the students to measure, for example, the variable star brightness, and they repeat the steps 100 times. They feel very boring, and they're very frustrating to do that, repeating 100 times. So what do you do?
Well, that's something that science is boring. It's not going to the beach. You must train yourself to be precise. They don't like to compute, to plan a graph. Yeah, but school is not for going. It's not comparable to going to the beach. The problem, the word I use. It's not a massacre. Massacre? Do you understand the word massacre? Massacre, but it's not beach time. So they must work. In the end, most of the child, if the teacher is, it's also enthusiastic, they enjoy it. I don't find. I remember, for example, one example that I in another context I use a lot is I drink a glass of water. How many molecules did I drink? Another. What's the weight of the air in this room? How do we compute that? Motivation can be intrinsic. It's not necessarily extrinsic. If you have a challenge, even those students that, not 100%, but most of the students are challenged by, most of the times, very simple things.
Okay, thanks again. Yeah. Okay, thank you. So our next speaker. Yes. So I think, yeah. So we need to have some technical arrangement. So it will be a 15-minute talk. I warned you for 5 minutes.
Yeah.
Yeah. So from Ron, so exploring the frontiers of science education with the support of the Inspiring Science Education Project.
Thank you very much. Good morning, ladies and gentlemen. It's very nice to be here. Thank you very much, Rosa, for the invitation. And I do have to say that my name is Sally Reynolds. I'm living in Belgium for the last 20 years, but before that I'm originally Irish. So I can tell you why you've got bad weather here this morning, because I arrived last night. I brought it with me. The good news is that I leave tomorrow morning very early. So hopefully you'll get some nice sun back. I was very disappointed to come to Portugal to the pouring rain this morning, let me tell you. So that's who I am. Maybe I'd just like to know who you are. How many people here from Portugal? Hands up. Lots of people from Portugal. How many people teaching? Any teachers? Okay. Nice to meet you. Hello. And people from other countries. I met some people I know from the UK. Where else are people from? Chile. Hi. Australia. Whoa, that's a long way away. Poland, not so far away. Hungary? Italy, great. So where are you from? Italy as well too. Good. So we've got, and I know a gentleman from the US as well. I heard you speaking this morning, so it's nice. Did we miss somebody, did we? From where? Brazil, long way away as well too. My, what an international group we have here this morning. So I won't take up too much of your time. I'm going to talk really about two things. I'm going to talk very briefly about the Inspiring Science Education project, which Sophocles mentioned already this morning, and which Rosa's involved with, and several of you probably already know a little bit about. There are leaflets about it outside as well, so I'll talk very briefly about that. But I also want to officially launch our competition for this year, because we have a really exciting competition in ISC this year, and it's all linked to the International Year for Light, so it's very nice to have the connection there as well. And the good news is that you in the audience also get a chance to enter a competition today, because I'm going to distribute these leaflets about our competition, and at the bottom you see a little tear-off strip. And if you'd like to enter our competition today, you have a chance to win a €100 voucher to Fnac. It says here Amazon. Ignore that. I couldn't get Amazon to work for Portugal for me, so it's Fnac. So what you do is you fill in your name and address at the bottom, and you leave it downstairs at the registration desk before 3 o'clock, and we'll do a draw, okay? People like me will do anything to get attention, so this is my way of getting your attention today. So I'll make sure these are distributed. Maybe, would you mind distributing them for me? Oh, would you? Thank you. That's very kind. So, let me tell you about ISE. This is a European Commission-supported project, a very large European project. I can't find the forward or back. Is that the forward? There we are. It's the mission behind ISE. In fact, I think the previous speaker to me really gives a very good example, because it's all about sharing resources and enthusiasm and interest in science amongst young people. When, for example, one of you asked, is it possible to actually have a look at the resources, these wonderful resources that were presented right before, it's quite hard to sometimes get your hands on these things. So what ISE is about, it's all about inspiring people in education in Europe around science education. We're about providing digital resources and opportunities for teachers to help make science education more attractive and relevant to students' lives. I don't need to convince people in this audience how important that is. It's also about helping students themselves to make their own discoveries and using interactive tools and digital resources. So that's really what the project is about. You'll see on screen, I can make these slides available afterwards if you'd like them as well, some of the things that we're about. Of course, it's not just about making resources available, it's also about building communities. And I think Sophocles this morning in his presentation described very well how important this is nowadays for teachers to work in professional communities, to have resources and people they can depend on, because we don't just go into a database out there. We take materials and resources from people we know who are already teaching well. We're also interested in people who are maybe addressing the same curriculum issues as we are. So as you could see this morning, this dependence on community and networking among teachers is growing, and that's what ISE is all about. It's about depending and supporting that particular kind of exchange amongst teachers. What we're about, of course, is popularizing science subjects in schools across Europe using information and communication technologies. The project is also a very large one, as I mentioned earlier. We've got 30 partners in 15 countries, including many experts in the field of science education. So there's a lot of experience, know-how, and resource in there. I'm coming from a small company in Belgium. Our particular interest is around dissemination, marketing, networking, and so that's the role that we play within the consortium. And we're also helping to build up a network of teachers actively engaged in this kind of work in Flanders, in the Dutch-speaking part of Belgium. So that's who we are. But as you can see from the next slide, we have all sorts of partners from different parts of Europe with many different kinds of experiences, knowledge, and know-how. I keep fiddling, looking for the right particular, there it is again. So these slides you will already have seen and know about. How many of you are involved in the activities of ISE here or ODS in Portugal? So you're very familiar with the work that Rose is supporting here, at the back as well too. This is a terrific network in Portugal. That's why it's so nice to come and to meet people here, and for the very kind invitation from Rosa, because you really are setting the pace in many ways across Europe with the kind of work that you're doing. I've just got pictures taken from our recent review, so to show you the kinds of examples. In Greece as well, we have a very active network of schools there, directly connecting, as Sophocles was describing this morning, schools to the research activities. And we've carried out a really extensive experience. In fact, during the last year, the Erasmus experiment was carried out with 303 schools across Europe, which is supported by the project. And it's all about that. It's all about exchanging experience, putting these schools in touch with each other, and seeing how best they can help to motivate and innovate science education in schools. So for teachers, there is an invitation. So for any of you who are not already involved in ISE, please join us. It's very easy to join the community. If you're not based here in Portugal, if you're in other parts of Europe, then you will find national contact points who will help you out with getting involved with the project. You don't have to be a particularly experienced school. Sometimes in Europe we have a tendency to only work with the really kind of experienced, dynamic, innovative schools, but there's also, of course, room for schools that are just getting started with this kind of work and using ICT. So it's an open invitation to any of you who are not already involved in ISE to join us. And if you want more information, I'm here all day and I'm very happy to share with you what's involved in the different steps of getting involved. We have tools and resources on our website, which you will see on all of the materials. You'll see showcases with examples of different kinds of resources that can be used in the classroom. Many of them are coming from other European initiatives, and I think that's one of the great advantages and good jobs that ISE is doing at the moment, is it's drawing together a lot of the different kinds of European shared experiences that have taken place in the past. There's a tendency in European projects that we all do something very actively for 2 or 3 or even 4 years, and then the project stops, funding stops, and everybody goes home. And I think one of the things that ISE is doing, and this kind of project is doing, is bringing together the resources and the materials that are emerging from these projects, which is very valuable. Just to put a small ad then in for activities that we're running, for example, in Belgium, this next school term, this is particularly aimed at teachers in Flanders. We'll be running several activities with our local ESA, ISERO office, tied very much to the Rosetta events, which you're all very familiar with. We're also working with another partner, Vernier, who you may be familiar with. They're a company supplying a lot of science classrooms with tools that are used in measurement and analysis. We're running workshops on using video coupled with these tools for our teachers in Flanders. And we're also providing an introduction to European projects in common with the Scientix project, which was mentioned this morning, which is a network for science projects across Europe between now and the end of the year. So we're quite busy with our activities in Flanders. So this is my job today, which is to launch our competition. It's called Playing with Light, and it's been put together by partners within the ISE network of partners, including Nucleo, with very much the support and help of Rosa and her colleagues. It's all about recognizing and rewarding inspirational science teaching practice. That point also came up this morning in some of the earlier presentations. Whatever about prizes for teachers, what is really important is, as a motivator, is recognition. Because for many teachers, and there are many of you in the audience, it's a lonely job. You work as best you can in your classroom, working with your pupils, and sometimes you achieve wonderful results. But who do you tell about it? You can tell your colleagues. Well, of course, a competition is another way of getting that kind of recognition. So I think what's most important about our competition this year is recognizing the excellent work that teachers are doing across Europe in their science classes. It's open to teachers who want to run an exciting experiment in their science class linked to light. And I think you heard all the different kinds of ways you could consider that this morning, from development work to purely physics to astronomy. There are lots of different ways you can run a project around light. It has to take place between now and March 31st. That's our deadline. And it's all about highlighting your work to schools and policymakers all over Europe. What we will do, and that's our job and our mission in ISE, is make sure people know about the finalists and the people who are doing excellent work as shown up by this competition. So, features of competition: you need to involve teachers in 2 or more countries, one of which has to be in Europe. So for our Brazilian and our Chilean and our Australian colleagues, you can also get involved, but you need a European school as a partner because we're funded by the European Commission. We have to make sure we do that as well. So please, if you're interested in getting involved, if you don't have contacts yet amongst other schools, we can help you in ISE in putting you in contact. But there is, of course, the e-twinning project, which was also discussed this morning, which I think most schools in Europe are well aware of now if they want to make connections to schools in other parts. We would like you to use some of the exciting resources and tools that are available in ISE, of which there are plenty. We're asking that you link the project to one of the so-called big ideas in science education, which I'll show you on the next slide. I think many of you in science education are familiar with this idea, this 10 fundamental ideas around science education. And it needs to be based on inquiry, of course, and they need to be projects that are innovative, exciting, creative, and engaging. This is the big ideas of science, where we are trying within ISE to, if you like, collate a lot of the work that's going on under these headings, under the big ideas of science. It's a way for us to, I think the question that was raised this morning about common curriculum in Europe is a very interesting one, because of course we don't, as Sophocles says, have a common curriculum. Education is still very much the responsibility of the state, or in some cases of the region, as is our case in Belgium or in Germany. But that makes it challenging for us to look at common topics, common ideas. And I think the big ideas of science is one way of categorizing some of the work that we're doing. And so we use it as a fundamental in our competition. Entering is easy. It's a 2-step process. Step 1, you need to register on our website. And when you register, you then download a simple worksheet, which you can use then to prepare your project and to report on your project. And it's that same worksheet that you send back to us by the 31st of March. So step 1 is to register and download the worksheet. Step 2, submit it by March 31st. So it's very straightforward in terms of a competition process, we hope. You can get support from ISE in terms of there's a community of teachers who will be also running competitions across Europe, and we'll invite you to join that if you can. You can also get information, as I said, about tools or resources, and also you can get in touch with your ISE national coordinator to let them know you're involved, you're engaged in this process during the year. What about the rules? We do have a couple of rules. One is the 2-step process. Secondly, it needs to be submitted in English. So it is a European international conference, so it needs to be submitted in English. You need to join the ISE competition community on our ISE portal, and at least one of the entries, one of the partners taking part must be from Europe, as I mentioned earlier. And that's it in terms of the rules. So 2-3 quick slides left. I'll be really quick. I'm Irish, I talk very fast. So judging criteria, those are the judging criteria, as you can see there: scientific accuracy, practical implementation of the project, cross-border collaboration. We really would like to have that as one of the focuses of the project. Challenge and exploration of the big ideas of science and use of the resources. Timetable, 31st of March. Judging takes place in April. And then what we will do is that we will invite the finalists, and I'm very glad to meet colleagues here from the Science on Stage project who'll be speaking later today, because we're going to take our finalists to London next June to take part in the Science on Stage conference and also to visit some museums there as well. And then the final note about prizes. Our finalists will, of course, be invited to come and join us in London, and we also will have resources and materials from Vernier as prizes for our winners and for our runners-up. So that's all you need to do now, is to enter our local competition. So you all have a piece of paper, fill in the bit at the end. Downstairs you'll find the box. Please put it into the box, and we will do the draw this afternoon. I'm going to ask my friend from the International Viera Light to pull out the final entry at the coffee break this afternoon to make sure it's all done above board. And that's it from me. There's my information. Thank you very much for your attention.
Thank you very much.
And I'm here all day for a chat.
So, one quick question. Any quick question? Okay, Farik here. Okay, thanks again. Yeah. Okay, so next speaker. So we did change the slides. Yeah. Okay. Okay. So. So the next talk is from a speaker from Gemini Observatory. So, Kasia, we talk about out of this world observatory careers. Gemini promotes observatory careers in host communities.
Yes, thank you. Hi, everyone. It's been a wonderful couple of days here in Portugal. It's my first time here in Portugal, and I want to appreciate the fact that in just 3 days, I've met people from all over the world. And that is definitely thank you to the organizers. So thank you, Rosa, thank you, Lina, and everybody who's made our stay so comfortable here. I normally present about our science results in Gemini. I am from Gemini Observatory in Chile. We are located in a small city in the north part of Chile. And we have a twin telescope that is in Hawaii. So all the outreach activities that we have to be shared among one side and the other. And we normally have a problem. The first one is the time issue, 7 hours difference. The second one, of course, is a geographical distance. But the most important one is that in Hawaii, the telescope is located at 4,100 meters above sea level. So nobody under the age of 16 can visit the telescope. So we have to manage to do many things for those children to get to know what we do, but most especially who we are and why are we there. So we came up with this pilot project that I'm presenting to you today, that it talks about observatory careers. Nobody, in Chile especially, in La Serena, being such a small town, we are the capital of the telescopes. And most of the people, if you go around, they will ask you, what do you do? And even if you tell them 100 times, they go, and what for? And how smart are you? Could I ever be like you? And they have these precious ideas that it's very difficult to make them feel that they could be part of this community, that it is for them, that it's open. So anyways, if you haven't seen, when you go to have the coffee time, we have this brochure, that is what I'm going to talk about. We have the issue in English, and the issue in Spanish obviously still hasn't come, but it will come, and it's available anyway, and I will let you know how to get it. So, that being said, okay, and since we are 2 telescopes and just 1 observatory, part of our mission in the public education department is definitely to promote and to share the opportunities that Gemini creates. We normally give the community the possibility to use our technology, using, for example, video conferences and having teachers coming with their students and communicate with some other teacher and some other students from another part of the world. We are available for the community. Our goal now is to share what types of careers, basically, and people make an observatory possible. So far, and honestly, before I even began working there, I didn't know how many careers, how many nationalities, or how many different skills were necessary to have a daily operation running smoothly. So this is what we're trying to do. We just released this brochure on, I would say, 6 months ago, and it's been incredibly successful because people has realized that they can be part of this world, that they don't have to be super smart, that they don't, not necessarily, but yes, they should speak English, but it will give them an incentive for them to do so. And every material that we prepare, it's always bilingual, in English and Spanish. Now, what I like the most about this brochure is the fact that for the first time we've done something that is completely interactive. Here you have, and I know you cannot read here the text, but this is the English version. All these people that we selected, they are from the different areas. We have the travel coordinator, we have the receptionist, we have the optic specialist, and everybody says what they do, but not with the title. See, if you look at the first one, Gabriela Randrup, she's a receptionist in Hilo, but she doesn't say they are Gabriela Randrup receptionist. She says, I am the first voice that most people hear when they call Gemini, along with doing a million other things. So you get to know the person and how is it that they are so excited with the job, what they do. Now that is the written part, but if you go into the link that will go later, each one of these characters, they have an interview, a very short video of 1 minute or 2 minutes long that is bilingual, according to what language they're speaking. So you can get to see them and hopefully share their excitement for what they do. And maybe say, for a kid in La Serena, Chile, to say, she's Chilean, or she's Chinese, and why not me? I could be there too. And is this moving? Yes, I think it moved. Oh, okay, that's the front cover in Spanish. And we repeat some people, but not everyone. And we try, of course, to emphasize that we also have women in careers, like the head operation of science, she's a female, as well as the engineer, Vanessa Montes. So also, it's very important for us to know that everybody is included. We do not discriminate in any ways when calling. Well, that link, I hope it works. And I just want to show you one that is very short, that has been very successful. You can click into there, but also we have the famous QR code here in the back. So most of the kids will just use their phone, and it will take you into that page. You can download the English version and the Espanol version in PDF, and you can have this. But also, if you go down a little, where is that arrow going down? Here should be. Oh, go down here. Help. Help. Okay, there we go. Did I? No. What did I do? I wanted to go down in that page. Yeah, it's coming. But I want to go down that page, and I didn't press the right, down, like out of that to see the videos. Like go down. Keep going down. Well, there you have all the people, what they do. They start coming, and just keep going. I'll tell you which one to show. And stop right there. Yeah, that's Gabriela. That's the receptionist. And I just wanted to show. How do you play that one?
You want to show this one?
Yeah, that one. I don't know if you can hear it, though, but let's see. Let's hope. They are all subtitled.
And I work here at Gemini. I am one of the administrative assistants here and also the receptionist. I'll be the first face you see when you walk in through those doors, and also answer all your phone calls. I kind of work like in a mini United Nations. If you've got a problem, as minute as maybe where I can get a cup of coffee, you come to me. Now, I won't solve any international problems, but I can help out with the easy stuff. I work with rock stars of the astronomy world, and that to me is pretty outstanding. With when you get to meet the Sandy Leggetts, the Scott Fishers of the astronomy world and what they've accomplished. I mean, I can say I've actually met them and I work with them on a day-to-day basis, which it's pretty cool. You're in Hawaii, you're working with great people, they're making great discoveries here. What is there not to love? I would encourage people who are you need to be outgoing, you need to want to help on a day-to-day basis, and love what you do. If you have that, I'd say please go for it. You got to just reach those goals and just go for it.
Is it working? It is. Okay, then I'll get it working now. The next slide. Well, anyway, you try to put the next slide. That's just one example that makes, that promotes basically and encourages students to go and be part of us. It's not so difficult. You see that she is real, that even that she is in a good mood. And well, Gabriela really is like that. It's not a pose. It's not a model. And you get to interact with them. Normally in La Serena, there's many, many remote areas where we go with our star labs, for example, or we take astronomers for the talk. And kids really look at them like it's another world. And with this brochure, what we have tried to do first is to tell them that the doors are open, that they could do it. Even if they are, some of them, they say, oh, they're coming, but I am bad for mathematics. Oh, no, I don't understand physics. And we say, well, you haven't tried this, but maybe there are other areas that they can make you immerse in this world. And also is something that has helped us strongly to boost staff morale. We're going through the transition phase in Gemini, in which this was very necessary. And even though at the beginning people would say, oh, no, I don't like cameras or whatever, at the end, they are very proud and they show their families that they're on the video. And we have seen that these have been clicked in the internet because we're starting to get the statistics now. So at the beginning, don't be afraid if you are doing something like that to get them all on camera, because even though they say they don't like it, when they are live, they do like it a lot. This is a pilot project anyway, as I told you, so we have many, many ways of improving, and I would like to hear many of your suggestions after this. Okay, we have several events in Gemini, and I'll be very quick on this, Gemini North and South, and we are almost 7,000 copies down. We printed a total 10,000 just like a pilot project, and we distributed already 7,000. It's not that we just distribute them like this to people that goes by the street. They come and they ask and they say, I want the career brochure because I want to be this and this. So it's not just like a given pamphlet, it's a brochure that has been requested to be given, and that makes us very proud. Well, we also presented a poster recently at the ASP meeting in July in the United States, and it was very successful. And how can you get your copy or tell your friends to get a copy? As I just showed you before, you can download it in the PDF mode at the Gemini page. And we're working now together with the AURA Association in Chile. AURA is the Association of the Universities for the Research in Astronomy that includes Cerro Tololo Observatory, Gemini Observatory, SOAR, and now LSST. So we're waiting for LSST to really be at least halfway built, and we're going to have a new edition in 2016 with people from all those observatories. We're currently developing a very, very simple and humble website tracking in metrics, so that can give you an idea of who is really looking at you. And with this, I'm almost done before you kill me. Okay, I don't know if you can see that, but we can really test right now that the United States, Chile, and then we have Canada, Argentina, United Kingdom. They were all partners of Gemini. So you can see who clicked, who saw it, how long they stayed on the page. That is an average of 2 minutes, which is pretty good for something that it looks very simple, but at the end it catches people's attention. And then from the region, you can see that many people from the region of Coquimbo, that is a tiny region in Chile, goes and clicks and reads about it because they see the telescope there. And now maybe they can be part of it, et cetera, et cetera. You can see details. And finally, okay, what we want to do here basically is to increase, first of all, the observatory awareness. Everybody, when we say we work in an observatory, they relate us to Tololo, because Tololo has been in the area since 1950. We are there only from 2001. So we want to, of course, promote the observatory, but we also want to make students aware of the possibility of training, of internships, of possibilities that they have as local students. We don't want them to have the image that only foreigners work there, and to make them proud as a local workforce that they will be. And well, also, of course, in the sense of the United States being part of this too, we want to expand the possibility of local hires for the key STEM career track positions. That's very important for us. We try all the time to do that and open the doors for that. And of course, try to broaden the participation of the observatory activities. We have many activities throughout the years. Some of them are annual, some of them come as they request, but we're always trying to be innovative. So this is our latest product, and as I say, it's a pilot project, so feel free to destroy it, give us suggestions, let us know how it goes, because it will be very important for us. And I finish giving you my information in case you want to visit Chile, to go to Gemini, or to get a brochure. I am the person in charge of the public office, public information office in Chile, and if you're going to Hawaii, it's Janice Harvey, my counterpart. So thank you very much, and I will be waiting for you in Chile.
Thank you. So, any questions? Any teachers would like to send your students?
There's just one, not a question, taking advantage, just
Yeah.
1 minute. Nothing to do with this, but we have 2 programs during the year in Chile to promote different activities. If you feel that you are didactic enough that you can teach without having a math and a number in your whiteboard, but not only hands-on activities, please contact me in the email, because we need people going to Chile to motivate our local students. So please contact me. We have funds.
Well, have funds. Okay, thank you. Okay, thanks a lot. Okay, so then, if no questions, then we'll proceed to the next speaker. So next talk. Yes. Okay. Yeah. So next talk is from Part2. Yes, Astronomy and Society, INF Education and Research Projects.
Okay. Good morning to everyone, and thanks to Rosa to inviting me in this, to give me this opportunity to speak here in this contest. I'm here to speak on behalf of a big group of people, which are my colleagues all over the country, all over Italy. We work for the National Institute for Astrophysics, which is a big institute made of 17 different institutes, astronomical observatories, but also institutes in which we study space technology and so on. We are 15 units of staff, but there are a lot of people. We have not permanent position in INAF, which help us in projecting, planning, and implementing our activities. There is enough, the National Institute for Astrophysics in Italy has a long story that here I have not time to tell you, obviously, but it is important to understand that we decided, recently we decided to create a group, to create a network. Why? Principally because we have the raw material, we have the research, and so INAF has as a primary goal the scientific research in astronomy and astrophysics, planetary science, cosmology, space science, and so on. But we, the people who are working in outreach and education, inside INAF has the raw material. And we have the duty to convert this material for school and for society. So one of the main goals of the National Institute for Astrophysics in Italy is also the dissemination of astronomical, astrophysical knowledge in school and society. And it is very important. And it is the reason why we created a group. But as you know very well, one of the critical point is always money, not only people and time, but also money. And so in 2012, we had the opportunity to be founded by the Minister of Education and Higher Research, our minister. We presented a proposal which is called Astronomia e Società tra Tradizione e Innovazione Tecnologica, Astronomy and Society between Tradition and Technological Innovation. And the proposal was approved on March 2013. It obtained a budget of about the maximum allowed by the minister, 300,000 euros, with a financing of 18%. That is, we obtained 300,000 euros, but we have to put also a 20% more of money. We started in April, and we are ending in this month, in September 2014. The big project, Astronomy and Society, has about 3 macro actions. The first is regards education activity for school. For example, training for students, refreshing courses for teachers, throughout the use of some particular tools that are, for example, laboratory activities and the use of professional astronomical instrumentation. A second macro action is the outreach activity, such as public events in our local institutes, for example, our astronomical museum, our astronomical facilities, and laboratories, and so on, but also public national events such as the Moon Night, the Moon Watch Night, the European Researchers Night, and so on, other public events which are coordinated all over the country. A third macro action is the multimedia and information and communication technology products. Here we are doing a lot of work because we are realizing a network of robotic telescopes for educational purposes. I'm going to describe it more quickly in another slide. We are doing a web platform for teachers, risorse educative per l'astronomia laboratoriale, that is educational resources for astronomy, and other important multimedia products such as the Astro Kids books that I will describe, and educational DVD, short 3D video clip, and so on. So one of the important points of our project, Astronomy and Society, is this platform for educational purpose, in which we want to collect a lot of material. We have a lot of material. We have created a lot of material, educational material, in the past years, but now we want to give them the availability in one single platform. And we want to integrate, for example, the platform Moodle with other platform which allow the people to have a friendly using of this material. edu.inaf.it is made with open sources resources, but it is developed also with the help and the collaboration of the National Council of Research and INAF. And now we are, it is a multi-site platform also, in which, for example, we have started astrokids.inaf.it, and also the website devoted to the International Year of Light 2015. we, for what regards the educational material, we are speaking with EAU for to have a connection with AstroEdu, the platform for educators, and we have had in this way the opportunity for collaboration with the EAU Office of Astronomy for Development. We have received the invitation to collaborate, to translate, to adapt in Italian our material and the material that are in EAU Edu platform. And for this, we have also we are establishing a peer review process and a group of people who analyzed and review the material that we are putting on this platform. We are working together with teachers, and before the first step was to give to teachers, to a lot of teachers chosen of different schools, a questionnaire in which they give us the input, the right input. Another product of this project financed by the Minister is the Italian remote network of educational telescopes, where the telescopes are all professional telescopes. We have 10 stellar telescopes, 5 solar telescopes, and 1 radio antenna. You can see the green one were already working before 2013. The red ones have to be converted, and the yellow are the work done during this project, during this 18th month of work. So another product, you have seen it in a poster, is this book. This book is not a mere book. It's not a simple book, because it was born by 4 years of experiences with the children. It is full of games, poems, stories, and games after every chapter. It tells the story of these children who is traveling around the cosmos, and we have also a website in which we put every day new materials, new video, new games, new proposal, and we will be very happy if this book could be translated, for example, in another language, in English, and used in schools or in other context. Another product very nice are 2 cartoons. 2 cartoons, educational cartoons, very funny. You can use it in a funny way, only the cartoons, only the music, and the discussion between Giga, the elephant, Stick, the mouse, the 2 avatars who are they are traveling the cosmos, planetary systems, galaxies, and so on. But you can stop in every time these cartoons and to have a deepening with educational material about the solar system and so on. And it is very funny. We have 2 cartoons of these, and we have a lot of radio astronomy. I'm going to finish, sorry. For radio astronomy, if you are interested, you can ask me then, because my colleagues gives me a lot of these materials. We have 2 national projects, 1 international, which is RadioNet, always the national financed by the Ministry, so Astronomy and Society. And okay, this is the project status in which we can see that we have done the most of the work. We have now to do the editorial board for the peer review process for the educational material, and we have to finalize the common user interface for the remote control for the network of robotic telescopes. And okay, I finished.
Thank you. So I want to ask the first question. So how do you assess the remote telescope? Is it available for all the people to use the remote telescope?
They are available, for now, they are available in Italy for schools, not for all people.
Okay, for
you
Italy.
have to be registered and so. But we.
So, for
it
example,
is-
other European countries?
Yes, it is integrated with the Virtual Observatory, VO, the project VO, and so we are studying the best interface to use it, to simplify it, because it's not, at now it is not simple to use it in schools by teachers, by people that are not astronomers.
Okay, thanks. Any question? Okay, so let's thank the speaker again. Okay, thank you. So the last talk this morning, yes, it's from Alexandra and Westry. No?
Yeah.
Yeah. I'm sorry. Okay, it's about creative and textile physics. So there are many pops.
Hello, everybody. I'm Alison. This is Ruth. And it's great to be here. And we've met so many people, haven't we?
Yes.
And we've talked to so many people. And what we're hoping today is that after we've talked about our project, you will come up with lots and lots of ideas for us as well. So that's why we're here. Our background is as physics teachers in the UK. But we have, for the last few years, been working with the Institute of Physics, designing workshops, delivering workshops to teachers to try and get them to get their nose out of the textbook and to do things. Our workshops are basically practical, aren't they?
Yes.
Yes. And on lots of different physics things. So what we're going to do in this presentation is talk to you about creative physics, tell you how it met tactile physics, and now how we're trying to get activities using all our senses. So,
You're going to see this photograph again this afternoon. It was taken at a big science outreach fair run by the University of Durham. And for the past few years, we've used our creative physics activities there. But this year, 2013, we used what you can see here, which is from Meet Our Neighbours. And I'll tell you more about it later.
okay, so creative physics. Creative physics was developed by some colleagues and us at the IOP, the Institute of Physics, basically as outreach, although you can use all these activities in classrooms, labs, etc. But it was outreach activities and has been used at science fairs, astronomy fairs. I've used it at the Devon Agricultural Show, science clubs, and certainly I've taken all sorts of things to WI's, that's Women's Institutes, I don't know if you know. But so a wide variety of audiences, a wide variety of ages. That we're not going to go to the hyperlink, but that is where you can get all the information about these activities. And there are three main things. One is about the planet, so we invite whoever's doing it to design a planet. And along with all these activities, it's the conversation that goes with it, isn't it? You know, is your planet going to be rocky? Those two are rocky. They're filled with rice, they're heavy. Does it have a pole? Does it have an atmosphere? Does it have rings? All those things. And the person who's designing it can do whatever they like with it. If you come to the workshop tomorrow, you can see how to make these things. But the great thing about certainly the rocky ones is that you can juggle, if I could juggle, you could juggle them afterwards. So, there we go, there's planets. Galaxies is, again, all these activities have, if you go to the website, you can see they are supported by lots of information. So there's lots of different galaxies, lots of different shapes, information about galaxies. And so, again, that can inform the conversation. So we both chose to do for this presentation a spiral galaxy, but we could have done all sorts of other things. Okay, and then we've got particles, which obviously are the basis for everything in life, physics, the universe, etc. And these are mobiles, particle mobiles. This one, in fact, is a Higgs boson decaying to 2 protons and then 4 muons. But it makes it, you see lots of pictures, 2-dimensional pictures. This brings it into 3 dimensions, which is good. Okay, so that's the creative physics. That's the basis that we were working from. And also...
Another project that the Institute of Physics did was physicists in primary schools. There's some lovely activities there, which we'll show you in the workshop if you come tomorrow afternoon. But linked to it, there is a PowerPoint. How sad. There's also a risk assessment. And also a script which enables professional physicists to talk at the right level to younger primary children. But there's some lovely images there as well, and some lovely activities.
One of which we're thinking of doing in the workshop tomorrow. Did you say that? You probably did, yes. Okay, so there's the Institute of Physics and activities, etc., going ahead in the UK. And then in 2013, Ruth and I were part of the UK delegation to Science on Stage in Poland. And there we met Lena and Isabel and saw their wonderful tactile stuff and the ideas that they had of bringing astronomy to the visually impaired. And we were just really intrigued, wondered whether our creative physics stuff, which of course can be tactile, we realized, could come together with them. So that's basically the road we're going along at the moment and why we're here to talk to Lena and Isabel and to all of you lot and to think about things. But it's certainly made us think in a very different way. Yes.
And this young lady made us think in a different way too, because if you look more closely at what she made, which is the sun, she actually put some straws through the buttons to make it really 3D. And she said that was a coronal mass ejection. It was obvious it came out of the sunspot.
Quite inspiring. Anyway, so a few of the things that have come up. I stopped Ruth buying a watermelon last night because she would have had to have carried it round all evening. But I suspect that you've all come across a fruit solar system, a fruit model of the solar system. Have you? Have you all met that? Yes, yes. But when you're thinking about sort of the visually impaired, then that takes on a whole, I was going to say new dimension, that's probably not the right word to use, but, you know, they can feel the size. It's a good, you know, size model. Then we came into, or I started looking at constellation lacing cards, and sort of there's the boring old constellation lacing card, which is good as well. You can, you know, a couple of students can be looking at that, lacing it, thinking of the pattern, because that's how we learn our way around the solar system or around the night sky. But then there are other things you can do with it. If you, instead of lacing it, put drawing pins, and we can choose different coloured drawing pins for different colour of stars, etc., and then lace it again and feel the pattern, and there's an awful lot to talk about Orion. I haven't even included the nebula there, but it can be done. So that's another way of using those, and then you can put straws through, and also then start a conversation about, are all these stars the same distance away? Oh no, they're not. So I'll probably choose the wrong one, but that one's closer, that one's further away, and you can, I've lost a star there, sorry. But you can then start relating it to the idea that stars are all different distances away from the Earth. In the sky at night, this is going on to another sense now, listening to meteors, and it was really interesting hearing the presentation yesterday, and it's always good to hear Bach as well. In the July edition of the Sky at Night magazine, there was an article about being able to use your FM radio to hear meteors. And there's all the details on that website. And that's another route that we're going down, to use sound as well, starting with this website probably. Do you want to talk about exoplanets?
This is not publicly available, but the Institute of Physics also runs a project for schools they support called Exoplanets, and I've just emailed them to say, did you know there was something you could do about naming exoplanets, which I think might be incorporated.
But hopefully there will be also material there that we can use in with a tactile approach. So what we're doing now is trying to put together a group of activities that will be good for both sighted and visually impaired people, that they will be able to learn and understand the universe better, and that we can present to them, to anybody, to visually impaired families, schools, whatever, at places like science centres probably, or something like that. But that's the idea at the moment. We'd welcome all your ideas. Thank you very much.
Great. So, any questions? So, thanks a lot, and please join the workshop. And there's a question.
So my question is, how easily can you incorporate all these activities in school? Are they welcome? How do you share this with all your colleagues?
The way we would share them sort of initially probably will be in workshops to teachers, and then they can go and do things in schools. But our other idea is actually not to use schools, but to use science centres, science hands-on centres, anywhere or planetaria, or wherever we can do a workshop and bring in a group of people that will be interested. And we hopefully would have them open to, a visually impaired person, their family, their friends, their whatever.
Thank you. Thank you for your talk, and I think it's quite incredible that the group of the people working with visual impaired activities is really growing really strong. It's really nice to see. Yesterday we had a presentation about music and outreach and education. Have you explored that way also to try to show to the visual impaired people how the universe works? And will you be interested in also exploring that new approach?
Not that. We haven't done that, but was it last week? Star Walk, which is an app for the iPad, produced Star Walk for Kids, which has some sound on it. It does need somebody who's visually aware to press the button, but we were actually looking as to whether we could link that to this as well. I know it's not sound as you mentioned it in music, but it is sound.
We have also been in touch with the schools for the blind, etc., and in principle they think it's all a great idea. It's getting it off the ground.
Okay, let's thank all the speakers this morning. Thanks a lot. So, and it's announcement.
So just a few announcements. We have changes in the program after lunch. The break will be only until 2:30, so we missed 20 minutes of lunchtime. We will have Babakta Freshi, that is confirmed. Instead of Michelle Fay, we are going to have Lina Canas talking about tactile astronomy. Bareket is not coming. We are going to have the talk by José Gonçalves, who was supposed to be on Friday, will be today in the afternoon. And Amelia Ortiz is also delayed at the airport, so she will take José Gonçalves' place, and instead of her, Bonnie is going to present, to give us a presentation. Also, I would like to say the following. Tomorrow, we have the outreach sessions of Europlanet Science Congress taking place in this room. Of course, this is on purpose because this is part of our meeting. So all the talks are going to be interesting from another perspective. But in the afternoon, so this is for the morning. For the afternoon, the outreach sessions are for the amateur astronomers community. There are also plenty of interesting talks. But in parallel with that, in the room next to this room, we are going to run workshops. So the first workshop is about the big ideas of science. I strongly recommend that you come. We want to hear your opinions about the big ideas of science. And the second one is about tactile astronomy. So please be with us in the workshops during the afternoon. We really need your help and your input, okay? So have a nice lunch. Try not to drown. There's a lot of traffic out there. I already know that. So we'll be back at 2:30, okay? Thank you.